The problem for number 5 asks, let g be continuous with g of 2 equals 5. The graph of piecewise linear function, g prime. The derivative of g is shown above for negative 3 is less than or equal to x, which is less than or equal to 7. Here is negative 3, and then to 7. Should we pause?
Find the x-coordinate of all points of inflection of the graph of y equals g of x for negative 3 is less than x, which is less than 7. Justify your answer.
Is this for pause? Is this pause?
It says R.
Oh. The answer for A is g prime has points of inflection at x equals 1, which is right here, because you can see it's going from increasing to decreasing, and at x equals 4, which changes from decreasing to increasing.
Find the absolute maximum value of g on the interval negative 3 is less than or equal to x, which is less than or equal to 7. Justify your answer.
This means that you have to include your endpoints. So, from our graph, you can see that g changes from positive to negative at x equals 2. So, if you plug it into your equations, you have g of negative 3 equals 5 on the interval 2 to negative 3, g prime of x dx equals 5 plus negative 3 halves plus 4 equals 15 halves. Then when you plug in g of 2, you get 5. And g of 7 equals 5 plus integral 2 to 7, g prime of x dx equals 5 plus negative 4 plus 1 half equals 3 halves. Now from all these values, you can tell that 15 halves is an absolute maximum.
Find the average rate of change of g of x on the interval negative 3 is less than or equal to x, which is less than or equal to 7.
Now for this question, you have to remember, or if you have not learned, you have to use your rate of change formula. The rate of change formula is as follows. F of b minus f of a over b minus a. Now from our previous information given to us, we know that 7 is b and negative 3 is a. So if you plug it in, you get g of 7 minus g of negative 3 over 7 minus negative 3 equals 3 halves minus 15 halves over 10, which simplifies to negative 3 fifths, which is your rate of change for this graph.
D. Find the average rate of change of g prime of x on the interval negative 3 is less than or equal to x, which is less than or equal to 7. Does the mean value theorem applied on the interval negative 3 is less than x, which is less than 7, guarantee a value of c for negative 3 less than x, which is less than 7, such that g double prime c is equal to this average rate of change? Why or why not?
Now for this, you have to use your mean value theorem. You have to use your mean value theorem to find the average value for g prime. So once again, you use 7 for your b and negative 3 for your a, and then you plug it into the equation. G prime of 7 minus g prime of negative 3 over 7 minus negative 3 equals 1 minus negative 4 over 10, which simplifies to 1 half. This means that no, the mean value theorem does not guarantee existence of a value of c, because there's points on negative 3 is less than x, which is less than 7, that are not differentiable.